Hello everyone, my name is Shashank, Master Teacher of Mathematics at Vedantu. We are going to present solutions of JEE Advanced 2019 Paper 2. In this video, I am going to present a question related to the topic matrix as in the paper. Let's have a look at the problem. It says let x belongs to capital R real numbers and let capital P be the matrix 1 1 1 0 2 2 0 0 3, capital Q is the matrix 2xx 0 4 0 xx 6, and another matrix R, capital R, is defined as PQ P inverse. In which of the following is oblique R are correct? So one or more option can be correct here. We'll look all the option one by one. Option A, there exists a real number x such that PQ is equal to QP, means P and Q are commutative. So we have to check it whether it is possible or not. Option B, determinant of R. R was defined as PQ P inverse. So determinant of R is nothing but determinant P into determinant Q into determinant P inverse. And determinant P inverse, we know that by property it is 1 upon determinant P. P is given to be a triangular matrix. Finding determinant by opening with the third row, we can see that the determinant of P would be the product of its diagonal element, that is 6. So P inverse is defined. So here determinant of R would be, and determinant of P inverse is 1 by determinant P. So obviously determinant R is nothing but determinant Q. Is it equal to, as we can see in the right hand side, it is written as determinant of the matrix 2xx 0 4 0 xx 5. It looks like same as Q, but only the just last element, here it is 6, here it is 5, are different, right? So determinant R is determinant Q. Is it equal to determinant when 6 is replaced by 5 plus 8 for all x belongs to R? We'll check it also. Option C, for x equal to 0, if R into the column matrix 1AB is equal to 6 times the same column matrix 1AB, then A plus B is 5. For x is equal to 1, there exists a unit, option D, there is a unit vector alpha I cap plus beta j cap plus gamma k cap, for which R into column matrix alpha beta gamma is equal to the null matrix 0 0 0. So let's see how can we solve it in a basic, easier manner. So one by one, checking the options. Option A, PQ is equal to QP. We need to check it. So for PQ is equal to QP, every element of PQ and QP should be equal. Like if I check the element of very first element, element of first row, first column, E11, if I compare, then from PQ you'll get the element of first row of P and the first column of Q. From there you'll get 2 plus 0 plus x is equal to the element of first row, first column of QP. So we'll take first row of Q and the first column of P, that would be 2 plus 0 plus 0. From here we are getting x as 0. So no problem, we can take x as 0, but if we take E12, so you will see that in the left, E12 of PQ is 1, right? It is x plus 4 plus x, and of QP, the first row of Q and the second column of P, that is 2 plus 2x plus 0, which gives us 4 is equal to 2, 4 is equal to 2, which is not possible. So this is not true. Option A in that manner, we can say, is not true. So option A is wrong, right? Okay, coming to option B, determinant of R. Now what is determinant of R? Determinant of Q, and determinant Q can easily be found using the second row. If you open the determinant Q using second row, you will just find determinant of Q to be 4 times 12 minus x square, right? So determinant of Q is 4 times 12 minus x square. For B, det of R is equal to det of Q is equal to 4 times, you can see, 12 minus x square. Yeah, det of the right hand side of option B, coming to it, det of this 6 is replaced by 5, so we'll say that right hand side is 4 times 2 into 5 minus x square, right? It was 2 into 6 minus x square. So this plus 8 was given here, plus 8 for all x belongs to R. So are we getting the same? Let's check. So it is 40 plus 8, 48. 48 minus 4x square is same as left hand side. So option B in this manner is correct, right? Option C and option D. We'll first check option D, then we'll go to option C. Option D says, yeah, for x equal 1 there exists a unit vector alpha I plus beta j plus gamma for which R into alpha beta gamma is equal to 0 0 0. Okay, R is P Q P inverse and P and Q are R into P. So here we need to check, see what is det R. Det R is 4 into 12 minus x square, as we found in option B also, and here in option D x is given as 1. So if you put x equal to 1 over here, so you'll get 4 into 11, that is 44. So it's not 0. So in fact what will happen, R inverse is defined. So R inverse is defined because R is non-singular. So we can multiply R inverse both the sides in the option D, then you will get alpha beta gamma as 0 0 0. Are you getting it? See what is given, R into alpha beta gamma 0 0 0. If you multiply R inverse, then you will get alpha beta gamma to be R inverse 0 0 0, which is 0 0 0. It means alpha beta gamma all are 0. So it's not possible for alpha beta gamma to be components of unit vector, because in that case alpha square plus beta square plus gamma square should be 1, which is not the case. So here we can say option D is also not correct. Now it's a fair chance for option C to be correct. Let's see. Option C, for x equal to 0, so we have to take x equal to 0 for option C, and then R, we need to check if R into column matrix 1AB is equal to 6 times column matrix 1AB, we can take the right hand side in the left and we can write R minus 6I times the column matrix 1AB to be the null matrix 0 0 0. Then we have to check that whether A plus B is 5 or not. So R minus 6I 1AB. Okay, so I'm taking it option for option D, R minus 6I into 1AB is equal to 0 0 0, right? Now R was given to be PQP inverse, PQP inverse minus 6I into 1AB is equal to 0 0 0. Continuing in this way, we can write PQ minus 6I. Okay, you can write it because P into I, 6I into P inverse is 6I. You can write it easily. And as P is invertible matrix, non-singular, so if you multiply both sides by P inverse, then we can easily simplify it as 1AB as 0, 0, 0. Here I have multiplied P inverse both the sides, right? So now Q minus 6i is basically minus 4. X we had to take 0, 0, 0, 0, minus 6i, according it should be minus 2, 0, 0, 0, 6, 0, 0, 0, okay, minus 6i now. And P inverse actually is what? P inverse we can find, P is given, it's very easy to find P inverse, and P inverse is adjoint P upon determinant P. Determinant P is 6, however we can ignore determinant because the right hand side is null matrix. So I am writing just adjoint of P here, and that would be for the very first element 1, it is 6. For the next element I will take adjoint of this, that is 3, okay, minus 3 here, and for this it is 0. Yeah, for the second row elements of adjoint we have to take cofactors of second column. So 1, for 1 it is 0, for 2 it is 3, yeah, for 0 it is 2, minus 2, and here you'll get for third row, third column 0, okay, then again 0, for 2 now it is 0, and for 3 it is 2. So we are getting this, and 1AB it is 0, 0, 0. This part is a little bit lengthy, so we can write then so multiplying these two, okay, you'll get minus 4, 0, 0, 0, minus 2, 0, okay, 0, 0, 0, then 6 minus 3a, then it will be easy if you multiply the later two. If you multiply the first and second matrix in the above equation, it will be more time consuming. So I am multiplying the later two. So 0, second row and first column, second row and the column is 0, then 3a minus 2b, 3a minus 2b, then the third row would be 0, 0, 2b. Okay, so it is 0, 0, 0. Comparing both the sides, you will get minus 4 into 6 minus 3a is equal to 0. Second element, 0 into 6 minus 3 into minus 2 into 3a minus 2b is 0. This and 0 equal to 0 from the third row. So from here we can easily see that the value of a is 2 and the value of b would be 3. So a is 2 and b is 3. So here, from here we can say that a plus b is 5. So option, in that way we can see that the option C is correct, isn't it? So finally the option B and C are correct in this question. I hope you understood the solution. You may go through the typed version also. Okay, B and C, correct, right? Okay, this is the complete solution. Okay, here should be A. So I hope you understood it. Finally, A is 2, B is 3. Option C was also correct. Stay tuned for the next question. Thank you.